Coming here, a 3-hour journey suddenly turned into a day and a half. I don't see very well, so in order to use my laptop, I have to use one hand and 2 fingers here, another hand and 2 fingers here to zoom in and out. It is my hope that at the end of this presentation, we can all think about leveraging all our great edge technologies today, robots that can do backflips, etc., to start helping out people with disabilities. I can argue right now that you are experiencing a learning disability, which is defined as any challenge in acquiring information. And I can also tell you that yes, the image is blurry by design. This is what it looks like to be visually impaired. Imagine if you're a kid in a classroom. Your peers that you're supposed to be competing with are learning, but you are stuck, just struggling to see. I am one of those kids. I am legally blind. Simply means that what you can see from 20 feet away, I have to walk up to it 1 foot away. But I wasn't born that way. I was born and raised in Nigeria, and I came to America with one purpose, to become a medical doctor. I arrived with $200, my dream, on a duffel bag. I missed the memo that I needed $200,000. So in order to be all that I could be, I joined our US Army. Barely 2 years into my medical studies and military career, things started going wrong. The first one is macular degeneration, which made me legally blind. It's a genetic defect of the retina. So that killed my military career and ended my medical studies. At that point, I was forced to switch gears, and I chose engineering. It was going okay with a lot of challenges, but after many years, that as well ended when 2 additional eye problems, genetic defects, were also discovered. If you're trying to wonder what it feels like juggling through genetic disorders of the eyes, imagine if your computer was dealing with 3 viruses. Tough to manage, difficult to cope with. So today, we're going to be talking about how to leverage all this great edge tech we have today to help out people with learning disabilities. The problem that people with visual impairment face is that the tech we rely on to cope with everyday tasks, they have this couple of drawbacks. They're manually operated, mostly handheld. Everyone is sitting and looking at you. What if you had to hold your eyeballs with 1 or 2 hands to be able to see that slide? That would be a poor user experience to limit your functionality and diminish your productivity. But this is what the visually impaired cope with today. Look at those numbers. That's the size of the problem. Over 300 million people worldwide today dealing with a 90% illiteracy rate. 9 out of 10 of them. This fuels a lot of poverty in the world today. And here in America, which is an advanced country, we have more than 20 million people that have to suffer the indignity of a 70% unemployment rate. I thought the national unemployment average was less than 4%. But things aren't moving very well for this demographic. Working age Americans end up prematurely in nursing homes because once they start experiencing vision loss, they get frustrated and they give up. And our baby boomers, 20% of them are affected by macular degeneration. So they all end up visually impaired. And that is what is fueling this continuous annual growth rate. Now, I'm going to tackle on Seeing AI, which is a great product by Microsoft. I'm not picking on them. I'm giving them kudos, actually. I like what they've done. Seeing AI is an application that you can download on your smartphone. And in essence, it converts your smartphone into a blind assistive tech. It leverages computer vision, which is great. It gets all that raw visual input analyzes, processes, and understands it. But it has a couple of drawbacks: handheld and manually operated. In order to use it, a user has to hold it, and if you give the person a business card, you choose the short text channel. If you give the person a one-page document, you choose the long text channel. If you give the person a $100 bill, you choose the currency channel. If you give the person 2 different colors, you choose the color channel, etc. It's great. I love the computer vision. I applaud them, but more needs to be done to increase the user experience. Now, for us to really tackle the manual operation, we have to think of a way to automate things. We have to think of a way to automatically detect visual impairment and then let that be the driver that calls upon the appropriate response of assistive technology. How can we do that? Let's look at non-invasive methods: electroencephalography, EEG, brainwave readers. These can non-invasively gather your brainwaves, and then we can leverage that data to be able to do certain things. We can apply machine learning. Just like computer vision, a machine gets raw input and processes and does all of that stuff, we can also apply that methodology to these brainwaves and just treat it as data. We can understand what it does, and when it figures out things like visual struggle, it can then throw out the appropriate signal to the blind assistive technology to aid the user and to increase their functionality and their capabilities. In this video, the user is simply looking at a clock, and when the EEG detects visual struggle, the Think and Zoom application running on Google Glass glues everything together, and the user is able to see hands-free and automatically. And we have a second video coming up. Hi folks, I'm in a restaurant and I'm struggling to see the menu. Take a look at that. See how blurry it is? This is what it looks like for those who are visually impaired. Is there an easy way for me to just see better? Is there an easy way for me to see the menu so I can just simply order something to eat? Can I use my mind to make that screen clearer? Let's give it a shot. All right, let's see what's happening now. Aha! It's getting clearer. And I see chicken. Folks, now I can look, think, and zoom in to see better into anything I want to see. More information at thinkandzoom.com. Think and Zoom. Look, think, and zoom into a better, brighter future. Thank you. So that second video was just, a step by step, because the first video could easily be a simulation. But in that second video, you can see how the brainwaves can be put to good use. This is, of course, a proof of concept at this point, and in the future, this is what we're looking at. And thanks to the folks at DACRI for this image. In the right hand, you see it all put together. That will take care of the handheld problem. And on the left hand, you see how it's all broken up. You can now have technology where it's gathering all the brainwave data, and then the lenses will act like a display. And all of it together will allow somebody to be able to look at something, and if they're struggling to see it, it can either magnify or apply text to speech or tell you what color it is or tell you what the person's face is. So this is how we're trying to look at a better future for those with disabilities and visual impairment. To date, we've been called to a number of places to share our message. We do some disability advocacy at the US Congress. We've been to a number of medical schools like Harvard, Johns Hopkins, and USC. And most recently, we're at the American Academy of Ophthalmology, as well as Singularity University, Exponential Medicine. To date, we've earned our patent early this year. We've also shared our message with TED Talks, South by Southwest, and at Apple, we received an award at Worldwide Developer Conference. That award was given to us because of our brain-controlled game. A lot of the public kind of freaks out and gets very concerned about when you mention brainwaves. So we developed a very easy and fun way for them to visualize their brainwave data. You're able to free a bird by simply thinking and get a score. So people love it, and it's a lot of fun. So folks, thanks for having me. My name is Zuby Onwuta with Think and Zoom, where we're creating a world where visual impairment no longer steals dreams or kills careers. You can connect with me via thinkandzoom.com or zubyonwuta.com. And we simply want to make the visually impaired have the ability to look, think, and zoom into a better, brighter future. Thank you.